Can you picture this? An interstellar visitor entering the solar system, yet almost refusing to shine. A path drawn straight and quiet, like a forgotten stroke of ink. A tail so thin that even the light struggles to find it. As it drifts past the Earth's neighborhood, all of it leads to one simple question that's hard to let go of. What makes 3I Atlas such a peculiar piece of the ancient universe? If you'd like, we can step slowly into the night together, follow that fading trace, and listen to the story it brings along. You picture it drifting toward us, not as a threat, but as a quiet traveler from a place our sun has never touched. 3I Atlas comes from beyond the boundaries of our own star's domain, carrying a chemistry shaped in regions we may never see. It approaches from distances so vast you stop trying to measure them. Instead, you feel them, like a deep breath stretching through the dark. For millions of years, it has crossed the space between stars, guided only by its ancient momentum and the subtle gravity wells it slips past. We watch its motion and sense its age in the way it glides, slow and steady, as if time itself has thinned around it. And somewhere in that long, silent journey, you start to wonder why its path, carved over unimaginable epochs, happens to brush so close to our small blue world right now. You watch its path unfold in your mind, still carrying the quiet wonder from the moment you realized it came from beyond our sun's reach. Now, as you follow the curve of its motion, something subtle begins to trouble your sense of what a comet is supposed to do. Most comets move in long, predictable arcs, shaped by the gravity of the sun, pulled into ellipses that feel almost ceremonial in their repetition. But 3I Atlas refuses that script. Its trajectory cuts through space with a sharpness that feels more like intention than accident. A line drawn quickly across a canvas too large for us to hold in a single glance. You sense it immediately, the way artists sense a stroke that doesn't match the hand before it. And in that difference, your curiosity deepens. We are accustomed to knowing where comets come from. We catalogue them, track them, map their returns like distant seasons. But with an interstellar visitor, the usual patterns fall apart. Its path isn't curved the way solar comets curve. It's not anchored to our star the way familiar objects are. Instead, its motion is ruled by velocities it gathered long before human eyes evolved to see the sky. When you try to picture how far back that story goes, you feel a small shiver, not of fear, but of scale. Something that has lived so long in the quiet dark isn't easily explained. As you trace its course, you notice how it doesn't settle into the balanced shape you expect. Instead, it slices through the solar system with the confidence of something that has never been here before and never plans to return. The line it draws looks less like the swooping arc of a comet and more like a single mark on a map that refuses to loop back to where it began. You imagine it rushing through the void, passing the outer planets without slowing, brushing the sun's presence only lightly before curving away again. Its path is neither chaotic nor simple. It is something else, something that makes us lean in. Scientists call this shape a hyperbolic trajectory. They say the numbers tell the story cleanly. A velocity too high for the sun's gravity to hold. A path that comes in once and leaves forever. But when you see that idea come alive against the backdrop of space, the mathematics becomes something more poetic. It is a curve that feels like a message written in motion. A reminder that not all things are meant to stay. A few astronomers have said that when interstellar objects pass through, they are like seeds carried by cosmic winds. One physicist phrased it differently. Every interstellar visitor carries a trace of the history that shaped it. And as you study the sweep of 3I Atlas, you begin to feel that history in the strange authority of its course. We often describe orbits as graceful, the slow dance of gravity and inertia guiding objects through the years. But 3I Atlas does not dance, it travels. It moves with the purposeful stillness of a traveler who has crossed too many miles to be distracted by anything along the way. You look at its trajectory and sense a past full of stellar tides, gravitational eddies, and close brushes with ancient suns that no longer shine. The line it follows now is the residue of those encounters, a path carved not only by physics, but by time, on a scale too vast for us to chart. You imagine the forces that may have shaped it. Perhaps it once belonged to a distant star system, drifting in the soft gravitational field of a sun we will never know. Perhaps a passing star nudged it free, or a cluster of newborn suns stirred the space around it, sending it drifting into the wider galaxy. It might even have been thrown outward by the collapse of a dying star, the shock waves of that event imparting just enough speed to send it on a journey that would last eons. When we speak of gravity, we speak of something invisible yet absolute, the quiet sculptor of the universe. And somewhere in its long journey, gravity pressed its hand against 3I Atlas and set it moving toward us. As you picture these possibilities, you start to see the comet's path as a kind of memory, written not in words but in motion. Each shift in direction, each faint curvature in its trajectory hints at a moment in its distant past. You realize that physics can be a form of storytelling, precise and impersonal on the surface, yet deeply connected to everything that has ever touched an object. The line that 3I Atlas draws through our solar system is not only a physical path, it is a record. You sense this as you imagine it passing by Jupiter, slipping through the sun's gravity well, bending but only slightly before continuing outward again. That subtle bend carries meaning. It tells you what the sun attempted to do and what the comet refused to permit. And yet, despite how cleanly we can describe the mathematics of its movement, there is still something about the shape of its path that feels off-script, almost unsettling in its simplicity. It doesn't spiral, it doesn't linger, it doesn't react the way you have learned comets react when they approach the sunday. Instead, it sweeps past with the calm certainty of something that knows exactly where it needs to be next. You catch yourself wondering why, out of the endless expanse of the galaxy, this ancient traveler has crossed paths with us now. It is a question that hovers at the edge of your thoughts, quiet but persistent. We often imagine the galaxy as chaotic, full of random movement and unpredictable encounters. But sometimes, when you look at the path of an interstellar object, you feel the opposite. You feel a strange order in the way its trajectory threads through our neighborhood. Even though the physics is governed by chance and velocity, there is a sense, however faint, that its presence here is part of a much older rhythm, one we are only beginning to notice. You try to explain that sensation to yourself, but words fall short. It isn't logic. It's a feeling born of the way the line looks when you let your mind relax into the scale of the universe. And as you study that line, as you let it unfold in your imagination, a deeper question rises beneath the beauty of its motion. It comes from that slight, enigmatic curvature in its course, the one shaped by forces we can describe, but not entirely trace back to their origins. It comes from the stillness in its speed, the way it holds direction like a memory it refuses to abandon. It comes from the simple fact that something formed in a distant corner of the galaxy is now sweeping silently through the reach of our sunday. You feel it gathering in your thoughts, quiet but insistent, like a whisper from the dark between stars. And with every passing moment, it draws you toward the same unresolved wonder. What could have bent its path into this precise, impossible line? You let your attention settle on its surface now, still following the quiet thread of its motion, still holding the question that lingered at the edge of its unusual trajectory. As 3I Atlas drifts into the faint light of our sun, the way it reflects that light immediately tells you something is different. Most comets brighten as they approach warmth, shedding icy grains that sparkle like scattered glass. But this one remains subdued, almost shy in the way it returns the sun's glow. Its surface does not gleam, it does not flare. Instead, it softens the light, as if every photon that touches it has to travel through something older than brightness itself. You notice how the reflection seems muted, as though some primordial dust is clinging to it, dust that has not been disturbed for millions upon millions of years. It does not scatter in vivid streaks the way fresh comet dust does. Instead, it forms a haze so delicate you almost feel it rather than see it. That faint, ghost-like dimness carries a kind of dignity, the way ancient stone absorbs more history than light. And as it drifts past, you sense that you are looking not at a simple icy body, but at a relic, a piece of matter left largely untouched since long before the sun was born. Scientists call this effect low albedo, a surface that reflects very little light. But even that term feels too small for what you see now. With 3I Atlas, the darkening is not a simple absence of reflection. It is the presence of something deeper, something that hints at an entirely different story. When you think about how sunlight interacts with that surface, you begin to imagine the microscopic grains that make up the outer layer. They are not sharp, crystalline particles, like the ones we know from comets that circle the Sunday. These grains feel more worn down, more traveled, as though they have been shaped by forces that work across interstellar distances. We understand dust in our own solar system. We know how it forms, how it breaks apart, how it gets sculpted by heat and collisions. But interstellar dust is different. It drifts through the galaxy for unimaginable lengths of time, collecting scars from cosmic rays, absorbing the faint radiation that fills the spaces between stars. In this kind of dust, molecules rearrange themselves slowly, responding to environments far colder and emptier than anything our world has ever experienced. When sunlight finally touches those particles again, after millions of years in the dark, it finds their surfaces hardened and worn, their chemistry altered by a history that refuses to reflect light cleanly. As you imagine the dust on 3I Atlas, you begin to grasp why its reflection looks so muted. Those grains have been traveling through the galaxy long enough to be changed by it. They are the product of places where matter drifts freely, where stars are born and die, where shockwaves move through gas clouds that stretch for light years. You picture the comet wandering through that landscape, gathering particles that settled gently on its surface like ancient snow. And because nothing disturbed them afterward, not heat, not radiation from a nearby star, not the gravitational pull of a planetary system, they remained there, preserved like artifacts inside a sealed vault. When scientists study that faint reflection, they look for patterns in the wavelengths that return to us. Those patterns tell them what kinds of molecules are present, how large the dust grains are, and how long they have been exposed to radiation. One researcher, watching the early data come in, said quietly, "This object is darker than it has any right to be." It was not a dramatic statement, but the tone carried something deeper, a sense of encountering matter that had lived a life very different from anything we know. In that darkness, they hoped to find clues about environments far beyond our solar neighborhood. You think about how scientists examine such an object. They watch for changes in brightness, looking for hints of volatiles evaporating off the surface. They compare the spectrum of its dust tail, however faint, to known materials in our system. If even a small portion of that dust contains organic molecules or unusual isotopic ratios, it could point to origins in a region of the galaxy whose chemistry differs from ours. And as they study the data, they begin to see subtle features that do not quite match expectations. The ratios of certain elements seem off, the grain sizes do not align perfectly with solar system norms, and the thermal behavior is slower, suggesting that the materials have been cooled to interstellar temperatures for a very long time. You let those details settle in your thoughts, realizing that the dimness of 3I Atlas is not merely an aesthetic difference. It is a fingerprint, a signature of a place we have never been. You imagine the comet drifting far from any star, its surface slowly accumulating the fine, ancient dust that roams the galaxy freely. That dust carries stories of supernova debris, of cold molecular clouds, of particles forged in places where cosmic rays carve into matter with relentless patience. The longer you imagine this, the more the dim reflection makes sense. It is not the darkness of shadow, it is the darkness of age. As the comet approaches the inner solar system, the layer of dust does not lift easily. It clings to the surface as though gravity itself has thickened around it, resisting the sun's warmth. The few particles that drift away do so reluctantly, and even then, they scatter light weakly, like ash falling through dim air. Our comets brighten quickly when they shed their outer layers, but 3I Atlas brightens slowly, as if awakening from a sleep that lasted longer than humanity has existed. Scientists often see material like this only in meteorites that have survived for billions of years, and even then, It is rare to find grains that match what they observe here. This dust is part of a different heritage. It belongs to a region of the galaxy where stars form in clusters, where gravitational tides shape dust clouds into long, flowing structures. If some of the grains on 3I Atlas contain traces of those environments, then each one is a tiny capsule of galactic history. They may hold noble gases trapped in their crystal lattices, isotopes formed by distant supernovae, or organic compounds shaped by ultraviolet radiation in interstellar space. You begin to feel the significance of it. By studying the way this dust reflects light, we are seeing a material record of regions far beyond our reach. The faintness of the reflection is not a void. It is a story told in subtle wavelengths, a gallery of ancient processes etched into the smallest of particles, and somewhere in that mix of grains, scientists notice something that deepens the mystery. A particular pattern in the way infrared light is absorbed, a signature that suggests the presence of molecules not commonly found in solar system comets. It is not definitive, not yet, but it is enough to make them pause. You feel that pause too, a quiet breath of uncertainty and wonder. Because if the dust contains materials shaped in a region of space with a different chemical fingerprint, then 3I Atlas is more than a visitor. It is a messenger, carrying pieces of distant stellar environments across the galaxy. And as you let that idea settle, calm and steady as the comet itself, the question rises with a quiet clarity. What exactly have scientists found hidden within that ancient veil of dust? You let the thought of that ancient dust settle in your mind, feeling how its muted shimmer hints at stories older than our sun, older than the planets circling quietly around it. And, as you trace those faint signatures of age, your attention moves towards something even more unsettling, something that lingers beneath the surface chemistry itself. The closer scientists look, the more they realize that 3I Atlas carries a composition that does not fit the profile of comets born within our solar system. Its elements seem arranged in a pattern that feels almost foreign, as though they were shaped in a workshop governed by a different set of cosmic rules. You begin to sense that the comet's shadowed surface holds not just dust from a distant corner of the galaxy, but the memory of a place we have never known. When you imagine the makeup of a solar system comet, you picture familiar ingredients: water, ice, carbon compounds, silicate grains, and volatile gases formed in the cold edges of our sun's protoplanetary disk. Those ingredients tell a story of formation at low temperatures, of material pulled together in the swirling outskirts of a young star. But with 3I Atlas, the story does not unfold so neatly. Certain elements appear in proportions that rarely occur in comets tied to our sunday. Some isotopes seem off balance, like notes in a melody that doesn't belong to our cosmic neighborhood. And as you let that idea sink in, you begin to understand that its chemistry is not simply different. It is displaced, bearing the fingerprint of another star entirely. Scientists studying its spectral data try to decode these ratios carefully, knowing that every element carries a history of stellar processes. Some materials form only in the outer shells of giant stars. Others emerge from the explosions of supernovae. A few require environments so cold or so dense that they can exist only in the cores of interstellar clouds. When researchers compare those signatures to what we see in familiar comets, the mismatch becomes unmistakable. One astronomer remarked quietly, "It's like reading a recipe written in the same language, but for a dish we don't cook here." The moment you hear that, you feel the difference. Not as an abstract idea, but as a kind of cosmic dislocation, the sense that this object's birthplace lies far beyond the warmth of our sunday. You imagine the star that may have shaped the ingredients now drifting through 3I divided by Atlas. Perhaps it was a red giant shedding its outer layers. Perhaps it was a heavy star nearing the end of its life, scattering its enriched elements into space. When massive stars die, they release clouds of material seeded with the heavier elements forged in their cores. Those clouds billow outward, mixing into the surrounding regions of the galaxy. If 3I Atlas formed from the remnants of such a star, then the comet is carrying tangible pieces of a sun that no longer exists. The thought has weight to it. You feel as if you are following a trail of ashes from a fire that burned out long before Earth was formed. In some of the preliminary findings, scientists noticed ratios of carbon to oxygen that differ from those seen in solar system comets. Nitrogen isotopes appear shifted as well, hinting at conditions that were colder or more energetic than the environments where our own icy bodies formed. A few of the mineral structures seem altered by cosmic ray irradiation at levels higher than most local comets experience. These clues form a kind of chemical accent, a way of speaking that reveals a heritage beyond our borders. You picture a vast molecular cloud deep in the galactic disk, rich with dust and gas left behind by several generations of stars. In those clouds, temperatures can drop to extremes we rarely encounter nearby. Under such conditions, molecules form differently, building layers that preserve the chemical imprint of the region. If the star that contributed to 3I Atlas material lived and died within such a cloud, then the comet formed from matter bearing the scars of that event. It is not just an object. It is a survivor of a stellar life cycle that never touched our own. The more deeply you think about this, the more the idea grows that 3I divided by Atlas is a fragment of a much older narrative. It may have been part of a fledgling solar system that never completed itself. It may have drifted near a young star cluster, where close encounters between stars are common. In such environments, gravity can fling objects outward, sending them into the galaxy as wanderers. A slight nudge at the right moment could have sent it drifting toward the open expanse, carrying with it the chemistry of its original home. As you let your mind travel through these possibilities, you imagine the pathways it might have taken. Perhaps it passed through the spiral arms of the galaxy, weaving between regions where stars form, then drifting through quieter areas where darkness stretches for light years. Along the way, cosmic rays would have altered its surface chemistry, smoothing some compounds and shattering others. Each alteration would leave behind a microscopic signature. Those signatures layered themselves over time, like the rings of a tree that mark its years in silence. By the time 3I Atlas reached our solar system, it was carrying not just the original composition of its birthplace, but the cumulative history of every encounter across its long journey. Scientists study these details with patience, knowing that each anomaly offers a thread to follow. When they analyze the dust, they find traces of isotopes with origins in high-energy processes. When they map its infrared absorption, they see patterns suggesting grains, shaped in conditions unlike those in the Kuiper belt or Oort cloud. One researcher summarized the implications by saying, "This object was raised in a different neighborhood." The simplicity of that statement carries a deep truth. Neighborhoods in the galaxy differ as much as climates do on Earth, each producing its own mix of elements and compounds. To find an object from another one is to glimpse a region of the universe through its matter rather than its light. You let the weight of that sink in, imagining what it means to encounter material formed under a star that may have lived and died long before our own sun existed. It is a reminder of how many stories remain hidden in the spaces between stars. When you think about 3I Atlas, you begin to see it not just as an object passing through, but as a fragment of a lost system, a relic of processes too distant for us to witness directly. Its chemistry becomes a message carried across the void, a testament to places where different rules of formation may have shaped the dust and ice. The more you reflect on these elemental signatures, the clearer the question becomes, the one rising steadily through the quiet rhythm of your thoughts. If the materials in 3I Atlas are unlike those shaped by our sun, if they carry the imprint of processes that unfolded under another star, then the path toward understanding leads in only one direction. Where in the vast universe did this ancient traveler begin its long and silent journey? You feel the question from before still echoing softly, the one about the vanished star that shaped its chemistry, but now your attention shifts toward the strange steadiness of its motion. Even after crossing regions of the galaxy where gravity ebbs and swells like a tide, 3I Atlas holds a speed that barely wavers. For an object drifting freely through interstellar space, this kind of stability feels uncanny. Most wanderers slow or scatter as they encounter gravitational fields, each encounter leaving a faint mark, a subtle change in momentum. But this comet moves as though the centuries have brushed past it without leaving a fingerprint. You sense that quiet steadiness, the way you might sense a still lake in the dark, perfectly balanced, untouched by wind. We expect celestial bodies to behave according to the invisible geometry of gravity. Stars pull, planets nudge, clouds of dust exert soft pressures that accumulate over time. Every object responds, every path changes, but 3i Atlas seems to resist those subtle adjustments, maintaining a velocity so consistent that it feels less like the natural drift of a comet and more like the glide of something held in place by intention. You imagine watching it from afar, following the faint arc of its motion across the darkness. It does not wobble. It does not lurch. It moves with a calm clarity that feels almost deliberate. Scientists measure its speed again and again, expecting small variations to appear as it interacts with the sun's gravity. They expect outgassing to push it slightly, the way gas jets from familiar comets create small but noticeable shifts in direction. But the jets of 3i Atlas are faint, nearly absent, and the slight adjustments they should cause never quite manifest. One scientist murmured after a long night of calculations, "This one just doesn't want to be nudged." And in that comment, you sense both admiration and unease. Objects this old should carry the marks of the forces that shaped them. Yet this one seems to have slipped past them, like a passenger moving through a crowded room without brushing against anyone. When you picture its journey through interstellar space, you realize how rare this steadiness truly is. The galaxy is not empty. It is filled with wisps of gas, dust, and fields of gravity that swirl and shift. Over millions of years, those forces can shape the motion of even the most distant travelers. A slight pull from a passing star, a brush through a molecular cloud, the faint but persistent push of starlight. All of these should have nudged 3i Atlas gently, altering its path or speed, but the record of its motion tells a different story. It suggests an object that has slipped through the galaxy, like a leaf moving through still water, untouched by turbulence. You imagine the forces acting on it as soft hands reaching through the darkness, each one trying to leave a small impression. Yet somehow, the comet drifts past them without absorbing their pressure. That kind of neutrality, that calm endurance, reveals something about the object's structure. Perhaps it is denser than most comets, its mass greater than we expect from something so dim. Perhaps its internal makeup is arranged in a way that resists the usual reactions to solar warming. Or perhaps the dust that blankets it forms a kind of shield, insulating it from the forces that normally reshape a comet's behavior. You try to picture this insulating layer, thick with ancient grains, absorbing heat and radiation without releasing the bursts of gas that shift a comet's trajectory. If this is true, then its steadiness is not mysterious. It is earned through age and endurance. But even as these explanations settle into your thoughts, another idea rises beneath them, quiet but insistent. Its speed is not just consistent, it is almost too consistent, the way a pendulum might swing if protected from the slightest breeze. That precision makes you wonder about the path it followed before reaching our solar system. If it passed through a region of space, unusually empty, far from any stars or clouds, it might have avoided the usual disturbances. But to travel that long without encountering any major forces seems improbable. The galaxy is wide, but it is not gentle. You recall the way its trajectory looked earlier, the strange simplicity of its line through space. And now, paired with this unusual steadiness, the line becomes even more intriguing. Objects that move freely for millions of years usually carry a kind of gravitational weathering. 3i Atlas carries none. It feels like a traveler who crossed a storm without getting wet. And that sense of untouched motion makes you wonder if there is more to its story than the simple drift through interstellar space. Scientists sometimes speculate about forces that act slowly, quietly, shaping objects in ways we barely detect. Radiation pressure can push a comet subtly, especially if it has a thin or reflective surface. Magnetic fields can influence charged particles trapped within an object. Even interactions with dark matter, though speculative, have been proposed to explain slight anomalies in long-distance motion. Most of these forces are too small to matter for typical comets, but for an object as old and lightly active as 3I, Atlas, even tiny influences accumulated over time could leave their mark. And yet, the comet's speed remains smooth, nearly pristine. You let that paradox rest in your thoughts. It is as though the comet is being carried by something rather than pushed. As though it is riding a current we cannot see. The comparison slips into your imagination before you can question it. A feather drifting in a stream that moves so smoothly you cannot tell where the water begins or ends. You know this is only metaphor, only a way for your mind to understand what the numbers suggest. But metaphors have a way of revealing the emotional truth behind the science. Something about its motion feels guided, balanced by a force too subtle to measure directly. And yet, when you return to the data, to the steady numbers that refuse to shift, you feel the same quiet question rising. It is the kind of question that scientists try not to voice too early, the kind that hovers in the background until enough evidence makes it respectable to ask. You hear it in the silence between observations, in the hesitant comments shared over late-night discussions, in the careful way researchers describe the object's strange consistency. Could there be another force at work? A force we have not yet fully understood, shaping the ancient and unwavering journey of 3I Atlas? You picture the comet's steady motion carrying it closer, its ancient dust still holding the faint memory of a star that no longer burns, its velocity still unnervingly smooth, as though time itself has been flowing around it instead of pushing against it. And now, as it enters the quiet outskirts of Earth's neighborhood, something in the quality of its presence changes. Not in brightness or color, not in speed or shape, but in the way it occupies the sky. You expect drama because we have been taught to imagine comets as messengers etched in brilliance, blazing with icy plumes and long, ghostly tails. But 3I Atlas refuses spectacle. Its approach is gentle, almost hushed, as if it is mindful of passing near a world that has only recently begun to understand how to listen. From Earth, its light is so soft that many observers describe it not as a streak, but as a whisper. Through telescopes, it looks muted, subdued in the most elegant way, the way moonlight settles on a snowy field without announcing itself. You imagine looking up on a clear night, expecting to see a flare, a shimmer, some radiant sign of its journey. Instead, you encounter a presence that feels less like an arrival and more like a drifting thought that has wandered into your awareness. Its dimness calms you, the way a still lake calms you when you lean over its edge and see your reflection ripple gently without sound. And as it draws closer still, slipping past Earth at a respectful distance, the sensation becomes even more pronounced. It glides with a rhythm so smooth that you begin to imagine it as a boat moving across a perfectly quiet lake. There is no splash, no trace of disturbance, only movement through space that seems to preserve the silence around it. The image surprises you with its clarity. A small vessel drifting across a surface the night has made glass-like, leaving only the faintest suggestion of a wake behind it. That is what its passage feels like. Less a celestial event than a moment of stillness stretched across the sky. Scientists marvel at this quality too. They expect the comet to brighten as it nears the sunday. They expect jets of gas to flare from its surface. They expect light curves that surge and pulse. Instead, the readings come back quiet and consistent, showing a brightness that changes so slowly it feels like the soft inhale and exhale of a sleeping creature. One researcher said, almost under their breath, "It's moving as if it doesn't want to disturb anything." You hold on to that line because it captures something essential. There is an intentional gentleness to its approach, even though you know that such a thing cannot be intentional at all. As it passes by Earth, the world below continues its daily routines. Most people never know the comet is there. They sleep, work, eat, dream, unaware that an ancient traveler is gliding silently past the planet, carrying dust older than human civilization. But you imagine the few who do look up, those who find themselves awake at the right moment, standing on porches or rooftops or balconies, letting the night wind brush against their faces. They may sense something unusual, not in the light, but in the feeling that the sky is holding a secret just beyond sight. You imagine yourself among them, the coolness of the night wrapping around you as you tilt your head back and search for the faint shape moving across the darkness. You find it not by brightness, but by stillness. Everything else in the sky pulses or twinkles or drifts with familiar motion. But this one point of dim light seems to travel with a strange, calm assurance. It reminds you of watching a small boat cut across a lake at dusk, the water so smooth that the boat's movement feels like a thought rather than an action. You cannot explain why the image fits so well, but it does, settling into your awareness like a truth you have always known. What makes the moment even more striking is how near its path seems, not in actual distance, but in the way it aligns itself with Earth's orbit. Many interstellar objects pass far from our world, their paths angled steeply or shallowly, slipping past without ever coming close enough for us to study them in detail. But 3I Atlas threads its way through the solar system with a precision that feels almost too perfect. Not dangerous, not threatening, simply close enough to be seen, observed, and understood. Close enough to remind us that the galaxy sometimes sends visitors that pass near enough to speak, without ever raising their voices. We know that its motion is not deliberate. We know that its trajectory is shaped by forces older and simpler than intention. Gravity, momentum, and the faint pressures of space have been carrying it for millions of years. And yet, as you watch it drift by, you find yourself wondering why this ancient object has chosen a path that brings it so near to Earth. It feels like a question suspended in the air, gentle but persistent, the way a ripple lingers on the surface of a lake long after the boat has passed. Scientists ask the same question, though they phrase it in more cautious terms. They wonder about the events that shaped its path long before it reached our solar system. Perhaps it was nudged by a passing star. Perhaps the collapse of a distant cloud shifted its direction. Perhaps it wandered through the outer edges of a star-forming region and was sent drifting outward in a clean, uninterrupted line. But even with all these explanations, its nearness to Earth feels unlikely, a coincidence so precise that it invites curiosity. You let that curiosity unfold gently as you picture the comet moving on, its soft glow diminishing as it continues past Earth and away from the sun's warming influence. For a brief moment, its presence felt almost intimate, as though you shared a quiet breath with something impossibly old. And as it slips back into the deeper dark, the question takes shape fully, settling into your thoughts with the weight of a mystery that has not yet revealed itself. Why, out of all the infinite directions it could have taken, did this ancient wanderer choose a path that brings it so close to our small and restless world? You still feel the quiet strangeness of its close passage, that muted glide that left no trail of brilliance, only the impression of something ancient drifting past with more calm than any comet you have ever imagined. But as 3I Atlas continues outward, slipping into the darker regions beyond Earth's orbit, a new layer of mystery begins to unfold. It arrives not in light but in data, in patterns so faint that even the instruments meant to capture them seem reluctant to make claims. At first, the variations appear as tiny fluctuations in radio noise, the kind of tremors you would normally ignore, artifacts of distance or atmospheric interference. Yet the longer astronomers study them, the harder they become to dismiss. You picture the observatories scattered across the world, listening to the sky the way you might listen to a quiet room at night, waiting for a subtle shift in the air. Some sit atop mountains, their dishes pointed upward with patient stillness. Others sprawl across deserts where silence is wide enough to hold delicate signals. These places are accustomed to noise, to whispers of radiation from distant stars, to the low hum of the cosmic microwave background. But what they begin to detect as 3I Atlas moves through the inner solar system is a kind of murmur that doesn't quite fit the patterns they know. Not artificial, not structured, just unusual. The first reports describe the fluctuations as slight oscillations in certain frequency bands, the kind of tiny deviations that look like imperfections in the data. But they reappear at multiple observatories, recorded at times that align with the comet's changing position. When researchers compare notes, the overlap is too clean to ignore. One scientist says, almost reluctantly, "It's probably nothing. But it's the same kind of nothing happening in three different places. There is a hesitation in that comment, the kind that arises when people feel a puzzle forming but do not yet have the edges of it. These fluctuations are not strong enough to be signals. They don't repeat, they don't carry patterns, they do not resemble any form of communication. They are just small shifts, slow pulses, like the faint trembling of a leaf stirred by air too soft to feel. You imagine watching a seismograph needle tremble without knowing whether the motion comes from the earth or from your own breath. The uncertainty has a way of deepening your attention. It makes you listen harder. As scientists examine the data, they begin to notice that the oscillations appear slightly different depending on the angle between the comet, Earth, and the Sunday. This correlation doesn't point to anything specific, but it does suggest that the variations are not random. They might be caused by solar radiation, interacting with some part of 3ATLAS, or by tiny changes in the dust or gas around it as it warms and cools. And yet, because the comet is unusually quiet, with almost no visible outgassing, even these natural explanations feel incomplete. You imagine the comet drifting through space, wrapped in its ancient dust, its motion steady as a heartbeat. Around it, space looks empty, but you know it is filled with particles, fields, and waves that move too subtly for the human eye to notice. Perhaps what the observatories are detecting is nothing more than this: the quiet interaction between a unique object and the light and particles that cross its path. But the more you follow that thought, the more you sense how unsatisfying it feels. Something in the data doesn't sit cleanly within the expected margins. It presses outward, just slightly, toward the unexplainable. A few scientists propose that the oscillations could be caused by interactions between the comet's unusual composition and the solar wind. If 3I Atlas contains elements not common in our system, or if its dust grains carry trapped charges shaped during its interstellar journey, then the solar wind might be producing weak, irregular responses. These would not be signals, just electromagnetic byproducts, harmless, unintentional. But even these explanations lean on speculations, on processes we know can occur but rarely observe so clearly. You think of the comet's long, silent journey through the galaxy, how its surface carries the memory of light from distant suns. If those grains have been altered by countless cosmic interactions, the resulting chemistry might behave in ways that feel unfamiliar to us. As radiation from the sun strikes the surface, it might dislodge particles in unpredictable rhythms, releasing faint electromagnetic ripples that drift outward like soft echoes. The idea seems plausible enough, but the truth is that no one knows precisely what combination of conditions would produce fluctuations like the ones being recorded. You begin to realize that the mystery does not lie in the fluctuations themselves, but in the coincidence of their timing. These oscillations appear only during a narrow window, only as 3I divided by Atlas passes a certain region of the inner solar system, and only at intensities that are barely above the threshold of detection. That timing makes you pause. It reminds you of catching a glimpse of movement in your peripheral vision, too brief to identify, too clear to ignore. You find yourself leaning into the uncertainty, trying to imagine what might be interacting with the comet to create what feels like a whisper in the background noise of space. Some researchers explore more speculative ideas. They suggest that the fluctuations might result from complex interactions between the comet's ancient magnetic fields and those of the Sunday. Interstellar objects sometimes carry remnants of magnetized material from their original environments, fossil fields that formed when the matter first coalesced. If 3I Atlas possesses such frozen magnetism, then its interaction with the solar wind could produce small variations, detectable by sensitive instruments. The concept intrigues you, the idea of a comet carrying a magnetic memory across millions of years. A few scientists point out that fossil magnetism could hold clues about the star that shaped the comet's chemistry. One researcher says, almost poetically, it might be carrying a magnetic shadow of its birthplace. The thought lingers with you. A magnetic shadow. The idea that something so ancient could still hold the imprint of the environment where it formed is both beautiful and deeply moving. It suggests a kind of continuity across time and distance that makes the galaxy feel smaller, more interconnected. Yet even as you consider this possibility, you know it is only one of many. The fluctuations could be caused by some physical process we barely understand, or some interaction between matter and radiation that rarely occurs in objects from our own solar system. The deeper you follow the thread of this mystery, the more delicate it seems. These are not strong anomalies, not clear messages carved into the noise. They are subtle, so subtle that scientists hesitate to assign meaning. And yet, the timing, the consistency, the faint alignment with the comet's position suggests that they are not random. You cannot shake the feeling that the fluctuations resemble something being carried, something embedded in the object's makeup, something revealed only under the right conditions. As you sit with that thought, the same question that scientists whisper to one another in careful tones rises softly in your mind. As steady and quiet as the comet's own passage, is 3I Atlas carrying something we have not yet learned how to see? You're still holding on to the faint question that formed as the data rippled across radio observatories, that quiet wondering about what 3I Atlas might be carrying. Not signals, not messages, but perhaps a kind of memory etched into its matter. And as you follow the comet farther along its path, your attention shifts towards something even more subtle, something that reveals itself only when sunlight brushes the dust behind it. Every comet produces a kind of atmospheric halo and a tail, formed when the sun's warmth releases gas and tiny particles from the surface. But with 3I Atlas, this release is unusual in its restraint. From a distance, the tail looks almost hesitant, as if it is forming out of a memory rather than reaction. It stretches behind the comet in a faint line that barely seems to widen, more a suggestion than a declaration. In typical solar system comets, outgassing can be bold, producing bright fans and streams that spread outward like illuminated smoke. But here, the tail remains thin, delicate, almost reluctant to appear at all. You imagine sunlight touching a surface that has been cold for longer than Earth has existed, light falling on ices that have never before experienced warmth from our star. And instead of bursting outward, the response is quiet, nearly imperceptible. Scientists study that faint release carefully, measuring the way it bends, the way it thins as the comet recedes. They expect common molecules: water, carbon dioxide, carbon monoxide, and other volatiles typical of comets formed near stars. And yes, some appear, but at levels startlingly low for an object approaching perihelion. One researcher puts it plainly, almost with reverence: it's barely waking up. You let those words echo inside you, because they capture something essential. This comet is reacting to the sun, not as something familiar, but as something unknown. Touched by warmth it has not felt for millions of years. The thinness of the tail reveals a truth about interstellar objects. Between the stars, temperatures drop so low that molecular motion nearly halts. Ice becomes rigid, dust bonds to surfaces in a way that resists release. A comet, drifting through that cold for such immense stretches of time, loses much of its volatile material. What remains is bound tightly, preserved by darkness and pressureless quiet. So when 3I divided by Atlas approaches the sun, the warmth does not coax it into the bright spectacle we know from comets that regularly cycle through our system. Instead, it produces only a whisper of gas, a breath of particles drifting behind it like dust stirred from a long-forgotten shelf. You picture the dust grains in that tail, lifted slowly from the surface. They're not fresh shards chipped from a lively nucleus. They're older, smoother, grains that have been shaped by cosmic rays, their surfaces etched by exposure to deep space radiation. As sunlight reflects off them, it creates a subtle glow, not sharp or shimmering, but softened by the same history that darkened the comet's surface. When the wind of charged particles from the sun pushes against them, the dust moves with a kind of fragile grace, like a thin veil released into a gentle breeze. Observatories detect these particles through the way they scatter sunlight and through the faint infrared signatures they produce. The results show grain sizes that are slightly larger and more cohesive than those found in typical solar system comets. This makes sense. Over millions of years, the smallest particles tend to erode away or be lost, leaving behind the larger, more resilient grains. These grains respond sluggishly to heat, explaining why the comet's activity seems so reserved. They also respond sluggishly to the solar wind, which helps explain why the tail remains so thin, so tightly drawn, instead of expanding widely behind the nucleus. You take a moment to imagine the long arc of time implied by these grains. To be shaped so thoroughly by the environment between stars, they would have needed to drift through extreme cold, enduring cosmic rays that sculpted them atom by atom. That kind of shaping does not happen over centuries or millennia. It happens over spans of time that stretch far beyond human history, far beyond the lifespan of civilizations, far beyond even the age of Earth itself. In that thin tail, you see the imprint of cosmic time, the slow and patient work of the galaxy acting on something that never hurried. Scientists compare the emission rates to models of interstellar object behavior and find consistency with objects that have been dormant for enormous durations. Not dead, not inert, but quiet in the way embers cool after a fire long gone. When they analyze the thermal response, the way the comet warms and cools, they find it lags behind expectations. The surface absorbs heat, but the release of gas comes later, slower, as though working through material that has compacted over unimaginable stretches of time. A researcher described it like this: "It's reacting on its own schedule, not ours." You begin to see that the thinness of the tail is not a mystery but a message about the comet's age. The longer a comet travels the dark between stars, the more its volatile materials decay or escape, leaving behind only the most tightly bound molecules. What you see behind 3I Atlas is the quiet residue of a surface that has endured longer than any human story. When you look at that delicate tail, you are seeing sunlight touching matter that formed in a distant system, drifted away, and then slept for millions of years in the cold depths of interstellar space. The dust grains continue to drift outward as the comet moves away from the sun, tracing a line so precise it feels almost contemplative. They do not rush. They do not scatter into broad fans. They stretch in a single, fine ribbon that follows the comet like a memory that refuses to disperse. And as you watch it fade into the darkness, the realization forms gently, the way a thought forms when you are lying awake in the quiet hours of the night. If a tail this thin reflects not weakness but age, if it reveals the slow erosion of volatiles through cosmic time, then one question settles into the space left behind, weightless but impossible to ignore. How long has this wanderer been drifting through the silent dark before arriving here? You follow the faint line of dust trailing behind it until even that begins to dissolve into the dark, and in the quiet that follows, your thoughts drift to the idea that has been forming slowly, almost shyly, ever since the first measurements revealed its age. Everything about 3I Atlas whispers of time, measured not in centuries or even in the histories of planets, but in eras that reach back to the early architecture of the galaxy itself. You sense it in the muted reflection of its surface, in the thin veil of its tail, in the isotopic fingerprints that do not match the chemistry of our solar system. Each clue points in a single direction, toward an origin so old that the Earth you stand on had not yet condensed from dust when this object began its journey. You picture the universe in its youth, a place still smoothing out the turbulence left behind by its own birth. The early galaxy was not calm the way it appears now. Stars formed in frantic bursts, lighting up clouds of gas that stretched for hundreds of light years. Regions collapsed under gravity, condensed, twisted, and ignited. In that chaotic environment, the first generations of stars lived fast and died violently, scattering their heavy elements into the vastness, enriching the material that would one day form new suns and new worlds. This was the era that shaped the building blocks of galaxies, the era that set the stage for everything that came after. If 3I divided by Atlas truly carries material from those times, then it is more than an interstellar visitor. It is a survivor from an age before the familiar structures of the Milky Way settled into place, before the sun circled the galactic center for the first time, before Earth existed even as dust. You imagine its earliest moments, a small fragment of ice and rock forming inside a collapsing cloud, seeded with the ashes of older stars. Perhaps it coalesced near a young sun that would one day fade without ever forming planets. Or perhaps it formed in the outskirts of a stellar nursery that scattered when its brightest members exploded. In that early era, debris was shed constantly, flung outward by gravitational encounters that rearranged orbits and sent objects spinning into deep space. 3I, divided by Atlas, may have been one of those fragments, cast into the galaxy long before stability became common. Scientists looking at its isotopic signatures recognize the possibility. Ratios of certain elements hint at origins in environments where temperatures fluctuated rapidly, where ultraviolet radiation was intense, and where cosmic rays streaked through dense gas clouds. These characteristics fit the models of matter formed during the galaxy's early generations. One astronomer put it in a way that stayed with you. If its composition holds, we're not studying a comet. We're studying a chapter of the galaxy's autobiography. The words strike you as more than poetic. They feel honest, an expression of how rare it is to encounter material that has remained so unchanged for so long. You imagine the comet drifting away from its birthplace, carried outward by the gravity of neighboring stars or by the shifting currents of the cloud from which it emerged. Over time, the galaxy's arms rotated, stars migrated, clusters dissolved, and yet the comet endured, untouched by everything that reshaped its surroundings. It became a wanderer not by choice but by circumstance, a small relic floating through a landscape that expanded and cooled around it. Millions of years became tens of millions, tens became hundreds. Entire star systems formed and faded, while 3I Atlas continued its slow, steady drift across distances that defy human comprehension. During those vast stretches of time, nothing happened quickly. Cosmic rays chipped atoms from its surface layer by layer. Dust settled in places where gravity could still exert a faint pull. Ice reorganized itself in response to pressures that built and dissipated over epochs. If you could watch it through all those ages, you would see it change gradually, the way a piece of driftwood changes shape as it moves through ocean currents. But those changes would not erase its ancestry. Instead, they preserved it, locking ancient patterns into place the way fossils preserve the shape of bodies long gone. You try to imagine the scale of that history. When the Earth began forming from the debris around the young sun, 3I divided by Atlas was already old. When the first oceans condensed, it was older still. When the earliest life emerged in shallow seas, it had been traveling for longer than life would take to evolve into anything recognizable. Every step of our planet's journey, every geological era, every shift in climate and species took place while this comet continued its silent passage far beyond the edge of the sky. You find yourself humbled by the comparison. Our entire story fits into a small fraction of the time 3I Atlas has spent in darkness. As it passes near the sun for the first time, its reaction is almost gentle. There is no sudden rush of gas or brightness. Instead, the comet warms slowly, the way an old object might warm after being taken from a cold room into the light. It does not transform. It reveals. What emerges from its surface is not new activity, but ancient character. Dust grains shaped in places we will never see, ice that remembers the radiation of distant stars, molecules that have drifted longer than Earth has existed. The tail it forms is thin because there is so little left to release. Time has stripped away nearly everything except what endures. You begin to see that 3I Atlas is not remarkable because it is mysterious. It is remarkable because it is honest. Everything about it speaks of age and persistence. It is a piece of the early galaxy that has remained intact through collisions, through radiation, through the slow dissolving of star clusters and the migration of suns. It has traveled through regions where gravity folds and stretches space, through dust clouds that drift like continents across the Milky Way, through magnetic fields that reach out like invisible tides. And yet, after all that, it has arrived here, close enough for us to see its quiet truth. Scientists look at its chemistry and see the possibility of learning about the conditions that shaped the earliest solid matter. They see clues about the distribution of elements before the sun formed, about the processes that governed early stellar nurseries, about the environments where the galaxy's first comets condensed. In 3I Atlas, they see a record written not in words but in the arrangement of atoms, in the structure of grains, in the way light reflects off a surface that has not been touched for millions of years. One expert says, almost in awe, "It's like holding a piece of time before time meant anything to us. You hold that image gently, a piece of time drifting, and as the comet continues outward, fading again into the cold, you feel the question that has been waiting patiently behind all these layers of age and distance. A question not about science alone, but about meaning. If this ancient traveler could speak, if it could recount everything it has witnessed since the galaxy was young, what stories would it tell about the moment the universe was just beginning to write itself? You feel the weight of its age still lingering in your thoughts, the way 3I Atlas carries the quiet signatures of a time long before Earth opened its first oceans or its first skies. And as that awareness settles, another realization begins to rise through it, something softer, something more personal. Everything you have traced so far, its muted glow, its thin breath of a tale, its ancient chemistry, its improbable steadiness, has led you toward a truth that is less about the comet itself and more about the place it creates for you in the universe. It is not a threat, it is not a spectacle, it is a bridge, a small silent thread connecting your brief moment of life to the vast uncountable ages that shape the galaxy. You picture yourself standing beneath the night sky, not as a spectator to danger or wonder, but as a witness to continuity. Above you, stars burn with the light of thousands of years. They seem distant, untouchable, fixed in their patterns. But 3I Atlas breaks that illusion. It is not fixed, it moves, it travels. It drifts across the sky, not for display, but because its journey has never been interrupted. In that motion, you glimpse something that stars cannot show you. The idea that the universe is not simply a backdrop. It is a place filled with travelers, with stories written in motion, with matter that can leave one star system and wander into another. Scientists see this too, though they express it differently. When they study the comet's composition, they talk about isotopic signatures and formation environments. When they examine its motion, they describe gravitational interactions and velocity vectors. But beneath all of that precision lies the same quiet feeling. This object reminds us that the galaxy is not separate worlds sealed away from one another. It is one continuous space, interconnected in ways we rarely have the chance to observe directly. 3I Atlas is special because it carries that idea in its very presence. You think about how rarely Earth receives visitors from beyond the sun's influence. The first confirmed interstellar object was detected only a few years ago, and it stayed in view for a short time before slipping into the distance. That discovery changed our understanding more than we expected. It showed that there are messengers moving between stars all the time, even if most pass by unnoticed. When 3I Atlas appeared, it became another reminder, not a repetition, but a reinforcement of something profound, that planetary systems are not isolated. That material can cross the immense spaces between stars, weaving the galaxy into a single, dynamic environment. As you sit with that thought, your perception of the night sky shifts slightly. Stars no longer seem like fixed points, but like homes scattered across an enormous landscape. You imagine each one surrounded by debris, by dust, by frozen bodies trapped in slow orbits. Some of those bodies are dislodged through gravitational encounters. Some drift outward after the death of a star. Some form in clusters that break apart. Over time, a few are cast into interstellar space, where they drift for ages until they cross the path of another star. 3I Atlas is one of these wanderers, and the mere fact of its presence in our skies means that Earth is part of that exchange, part of that endless sharing of matter. This is what makes it special. Not danger, not beauty, but connection. You feel that connection more deeply as you imagine its passage through the inner solar system. It comes quietly, it leaves quietly, and yet, in its presence, it brings with it the memory of a world you will never see, A star that may no longer shine, a region of space that formed long before ours. It is like finding a stone washed ashore from a continent across the ocean, shaped by waves that never touch your own shores. The stone itself is small, simple, familiar in form, but the story it carries expands the map of everything you know. Scientists sometimes speak about these visitors with an intimacy that borders on reverence. One said while reflecting on its age, "It reminds us that we're part of something larger than our own sky." The line stays with you because it captures the way 3i Atlas shifts your sense of scale. You are no longer just observing a comet. You are brushing against a fragment of the galaxy's early life, something that has moved through regions of space you cannot imagine without feeling your breath catch slightly. And yet, the most profound part of this connection is not scientific, it is emotional. Something happens when you realize that a piece of matter older than Earth has come close enough for you to see it, if only faintly. It calls to something quiet within you, the same instinct that makes people look up at the stars, the same curiosity that makes a child reach towards something beautiful and distant. 3i Atlas becomes a reminder that the universe is not indifferent. It is vast, yes, and cold, and ancient, but it is also full of paths that cross, full of travelers that drift close enough for us to notice, full of opportunities to understand where we fit within the story of everything. You feel that more deeply when you think about how fragile and temporary our presence is compared to the comet's journey. Earth will not last forever. Neither will the Sunday civilizations will rise and fall. Oceans will shift, continents will break. And yet, objects like 3i Atlas will continue drifting, carrying memories of stars long gone, of eras we can only reconstruct from faint isotopic hints. When you encounter such an object, you are reminded that the universe is not defined solely by its changes but also by the persistence of certain things. Persistence not as endurance against time, but as proof that some stories stretch far beyond the reach of any single world. You begin to understand that this is why the comet is special. Because in its quiet, unassuming way, it offers perspective. It softens the boundaries of the familiar. It reminds you that you are standing on a world shaped by the same forces that shaped distant systems, that your atoms and its atoms were forged in the same cosmic processes, separated only by time and distance. When you look at 3i Atlas, you are not looking at something alien, you are looking at something ancestral. And as the comet continues its path, slipping away from the sun's influence and returning to the quiet dark that shaped it, one final thought rises gently into place. It is a thought formed from wonder, not from fear, a question shaped by your own sense of belonging within a universe that is far wider than your nights can hold. There is still one last thing that makes this ancient traveler a rare gift for this particular night, one final truth that settles softly between the stars, waiting for you to notice it. You can feel the quiet settling now, the way the night sometimes softens around you when a long story reaches its final turn. The path of 3i Atlas drifts farther into the dark, and the immense scale of its journey begins to fade back into the sky. What lingers is not the data or the distance, but the stillness it leaves behind. A reminder that even in a universe shaped by fire and gravity, there are moments that ask nothing of you except to breathe and to listen. In that calm, a small thought rises like the last ripple on a lake after the wind has passed. This visitor, wandering longer than Earth has existed, brushed past our world without ever meaning to, yet its presence opened a window, a brief one, onto the deeper rhythms of the galaxy. It is humbling to realize how many such stories continue unobserved, how many travelers cross the dark between stars, carrying the quiet memory of places we may never reach. Tonight, you've touched one of them, if only in imagination, and that alone expands the edges of what you carry with you. If the night still feels open, if a part of you wants to drift a little further into the quiet, you are welcome to stay with Bedtime Science Stories on the nights ahead. These journeys are gentle by design, a place where wonder doesn't rush, and where the universe feels close enough to rest beside for a while. For now, Let the story settle the way starlight settles on an empty field, soft and unhurried. And when you're ready, we'll meet again beneath the same wide sky,